All right, so let's take a look. In my recording? All right, I think so. Let's take a look at this problem. Boy, we've got a fifth degree. Is it in standard form? 5, 4, 3, 2, 1, constant term. With this being 1 and 5, I don't see any number that divides all of these, so there's no greatest common factor. Um, I'm ready to look at my factors of my constant term and the factors of negative 45. Let's list those. Plus or minus. These are the integers that divide 45. 1, 3, 5, 9, 15, and 45. And the leading coefficient of 1, factors of 1, well, that's just plus or minus 1. So the list of possibilities for rational x-intercepts, for rational roots to this equation, is just one. This is my possible numerator. This is my possible denominator. So I have 1 divided by 1, which is 1, and then 3 divided by 1, and 5 divided by 1, and 9 divided by 1, and 15 divided by 1, and 45 divided by 1. So I don't see any trick that would get me to, through my just normal factoring skills. There's definitely no X method, and I don't see any factor by grouping that would really work. So I'm just going to have to jump in and try and start using these values. I'm just going to pick ones and negative ones in the beginning because that's going to be easiest to do arithmetic on. And, you know, I often look to see if this is all addition or, all subtraction to where, well, especially all addition, to where how can they all add positive numbers, all add up to 0. But in this case, I can't even eliminate any from this list immediately. So I'm just going to have to go through the list. And I recognize I might go through this entire list and none of them might work. This equation might not have solutions that are rational numbers. They might be, an irrational number, or all, one irrational number, and all the rest complex numbers. So let's look and see what we have here. We've got 1, negative 5, 10, negative 50, 9, and negative 45. Let's see if I get a 0 here. 1, 1, negative 4, 6, 6, negative 44, negative 44, um, negative 35, and that's definitely not 0. So let's try a negative 1 and hope I didn't make a silly arithmetic error in going through that. I don't think I did, but yeah, see, I'm not getting a 0 here either. So I can scratch off 1 and negative 1 from the list. Alright, so let's try to look at 3 and negative 3. Alright, I don't want to make a mistake. I've been here for a while today, and even if I'm not tired, I make mistakes, so I don't think this is going to work. What do you think? Because when I multiply that by 3, this is, I needed this to be a positive 45, so this is definitely not 0. So let's try negative 3. This doesn't look very promising either, does it? Yeah, how is this going to end up being a positive 45? So I can scratch off 3 from the list, 3 and negative 3. So let's try the next one. Let's try 5. Hey, there we go. We got a 0. Okay, so we had to go through a few of them to get it, and sometimes you even have, like I say, you might go through the whole list and none of them are. Alright, so what does that tell us? That tells us that we can factor this left-hand side, that if 5 in synthetic division, if 5 was an x-intercept, that in factored form, it's x minus 5. If this was x to the 5th, then down here is 1x to the 4th. There are no x cubes. There's 10x squared. There's no x's, and there's 9. Now, this is where if you're good at factoring, it pays off here. I know that I can factor that and stuff. But let's suppose I didn't recognize that. Let's return up here to my original list and write a modified list. If I'm trying to, factor this with this rational root theorem, the factors of my constant term 9, well, they're in this list because 1, 3, and 9. These larger numbers, 15 and 45, don't divide 9. And of course, my leading coefficient was 1. Don't forget our plus or minus. So my list for this one, not the list that they asked, the list that they asked for is this one for the original function. I'm just trying to factor this completely using that list. So I generated a second modified list of this to help me with this degree 4 expression. All right, so let's do synthetic division now. The list that this generates: 1 divided by 1, 3 divided by 1, 9. It's this factors of 9 list all over again, and this one is a little bit interesting to me versus the original that had pluses and minus terms. This is all positive terms. So I'm not going to bother with positive numbers in the synthetic division because positive numbers aren't going to add up to 0. I need this factor to be 0 so that 0 times this, x minus 5, is 0. So I need to try negative 1, then negative 3 and negative 9. And like I say, maybe none of them will work, but I suspect that one of them might. Now, I don't have an x cubed term, so don't forget I need a 0 there. Then x squared, I don't have an x term, I need a 0. And then I have 9. So let's look and see what we get here. I'm going to have to scoot this down a little bit, aren't I? Because that's right up in my work area. Alright, I'm going to pull this, well, if I can pick the writing tool, I'm going to pull this number down, multiply it by negative 1. And I do not get 0, so I'm going to throw out positive 1 and negative 1. I need to throw out positive 1 because they won't add up to 0. So let's try negative 3. 1 comes down. Oops. Listening too much to these comedians, and it's making me laugh. Well, not making me, distracting me. I think lack of sleep is causing me not to laugh. Negative 57. No way is this going to add up to 0. I'm going to stop here, so I'm going to throw that off the list. Alright, so let's try 9 and negative 9. Now hopefully I tried positive 3. Well, again, no I didn't, because these are all, I'm just trying negative numbers. because I know positive numbers won't work. So this is not going to work either. This is not going to be 0 over here. So let's look, if this isn't contributing any rational zeros, then my answer is x equals 5 along with that list. Let's use my factoring skills to kind of confirm that. I know that x squared plus 10x squared plus 9 factors to x squared, and two numbers that multiply together to give me 9 but add together to give me 10 plus 9 plus 1. And I'm not surprised at all now that I couldn't find another 0, because there are more. The 5 is the only rational 0 for this whole expression here. I know that here that this produces two imaginary numbers. X squared is only going to be a negative number in the set of imaginary numbers, complex numbers, and same over here, that x squared is never going to be a negative 1. So this is contributing 2 degrees, this 2 degrees, this 1, and 2 plus 2 is 4 plus 1 is 5. So I know that, but with this additional knowledge of factoring this, I know that this equation has one rational solution and that it has 4 imaginary numbers that are solutions to this. I'm only interested in this. I'm just giving you that additional information. This is our answer, x equals 5. And here's the list that they wanted. So hey, I hope that helps. I think this was the last problem, and I'll talk to you later.